Hello students. Welcome to today's class. We are going to talk about scalar and vector quantities. Before we proceed with today's lesson, remember, in our previous class, we understood the concept of rectilinear acceleration. We also discussed how to plot and interpret acceleration on a velocity time graph. By the end of this lesson, you should be able to understand the concept of scalar and vector quantities. Distinguish between scalar and vector quantities. Now, without further delay, let us dive into today's topic. Let's dive in and explore this concept together. Scalar quantities are physical quantities that have only magnitude, but no direction. In other words, scalar quantities are described solely by their numerical value, without any reference to direction. Some examples of scalar quantities are mass. Mass is the amount of matter in an object. The SI unit of mass is kilogram. Some other units used in measuring mass are grams and tons. Temperature. Temperature is a measure of the average kinetic energy of the particles of an object. The SI unit of temperature is Kelvin. Some other units used in measuring temperature are Celsius and Fahrenheit. Time. Time is a fundamental quantity that measures change or the interval between change in a physical stream. The SI unit of time is seconds. Some other units are minute, hour, day, week, and so on. Speed. Speed is the rate of change of position of an object in any direction. The SI unit for speed is meter per second. Other commonly used units are kilometer per hour, miles per hour, and many more. Other examples of scalar quantities are distance, energy, and volume. These quantities are all described solely by their numerical value, without any reference to direction. Example: a bicycle weighing 11 kilograms. An athlete running at a speed of 12 meters per second. These representations convey the magnitude of the scalar quantity, without any reference to direction. Next, we are going to talk about vector quantities. Vector quantities. Vector quantities are physical quantities that have both magnitude and direction. In other words, vector quantities are described by both their numerical value and their direction. Some examples of vector quantities are displacement. It is the distance an object moves in a straight line, in a given direction from its starting point. Example: a girl running 5 meters east. The SI unit of displacement is meter. Velocity. Velocity is the speed in combination with the direction of motion of an object. Example: a car moving 20 kilometers per hour west. The SI unit of velocity is meter per second. Acceleration. This is the rate at which velocity changes with time, in terms of both speed and direction. Example: an apple falling down a tree. The SI unit of acceleration is meter per second squared. Force. Force can be described as a push or pull that can change an object's position, speed, or state of motion. An example is a magnetic force pulling a nail upward. The SI unit of force is Newton. If you observed well, you can notice that these quantities all have both magnitude and direction. Next, we are going to talk about the differences between scalar and vector quantities. In physics, all measurable quantities can fall into either the scalar quantities or the vector quantities. Here are some common differences between scalar and vector quantities. Scalar quantities have only magnitude with no direction, while vector quantities have both magnitude and direction. Scalar quantities are represented by numerical values only, while vector quantities are represented by arrows or bold-face notation. Examples of scalar quantities are mass, temperature, time, while examples of vector quantities are displacement, velocity, acceleration. Understanding the difference between scalar and vector quantities allows us to accurately describe and analyze physical phenomena. solve problems involving forces and motion in multiple dimensions. It also allows us to make informed decisions in various fields of physics and engineering. Good job, students! I have 3 assignments for you to work on. Number 1. List 2 examples of scalar and vector quantities. Number 2. List 2 applications each of the examples listed above. Number 3. List the similarities between scalar and vector quantities. You've got this. Before we end today's class, let us summarize on what we learned. Today, we learned about the concept of scalar and vector quantities, the differences between scalar and vector quantities. Alright students, you did a great job today. In our next class, we are going to talk about work and power. Thanks and goodbye.